Hi everyone! Today I'm going to show you how to create digital form of the correctional link for the automatic control system in CoDeSys. So let's say that we need the correctional link for our automatic control system, and its transfer function looks like this. Of course, we have some digital values behind these two variables, which, for example, we have obtained from some optimization procedure. But this is another story. So we have this correctional link in continuous form, and before we can program it using some controller, we need to transfer it to the digital form. So using the rule of the first difference in digital control system theory, we perform these two simple mathematical steps, and we receive the transfer function and the output of our block, of the correctional link block, in the digital form. So using this, we can start coding it. So let's go ahead and start CoDeSys. I will create new project. As we're using the dynamic links, I will append new task, which will be called each 100 milliseconds, and I will add our program call for it. So every 0.1 seconds our main program will be called. Okay, and now we can start creating our dynamic link for our correctional link. So we add new object. It will be function block in the ST language, and we give it a name. Okay. So now we must look at our expression. So which we have? We have output, input, input of the previous step, output of the previous step, the input variables t1 and t2, and the sampling time, which is 0.1 seconds for my task. Okay, so let's declare variables. So input t1 real, t2 real, okay, and the output will be output of our correctional link, and we have two common variables, which is the output of the previous step and the input of the previous step. Okay, so we will evaluate our output, and after each step of our evaluation, every 100 milliseconds, we will rewrite our previous step for the current. And here we must put this expression. So it's input t2 plus tk minus t2 and the input of the previous step plus t1 output of the previous step and divided by tk plus t1. So let's check it again. Current input t2 plus tk. Current input t2 plus tk minus t2 the input of the previous step and plus t1 the output of the previous step and divided by tk plus t1. Yeah, that's correct. So now we can insert a box, type the name of our block, and now we have created our correctional link. Okay, let's add some constants. This 0.1 and the input will be, for example, 10. And I will create global variable so we can later use it in a visualization. Let's just check if everything is correct. So I'm going to log in and start. Okay, it's calculating, so there are no major errors. And now we can add some visualization. Okay, we will choose our variable, the output of our correctional link block. And now we have to adjust our scale settings. Okay, we can log in and run. And here we can see okay, I will log out for the moment. Okay, log in again and run. And here we can see our transient process, which represent the output variable coming from our correctional link. This one, which we have transferred into the digital form and have written using this code. So this string represents this expression, and also we use two additional variables for the memory purpose of the previous step of the input and the previous step of the output. And clearly we can see that everything is working just fine. So that's how you create a digital realization of the correctional link for automatic control system in CoDeSys. In fact, I have showed you the principle, and I hope you have got it, because this correctional link in fact can have many different forms. For example, for your system it can be something like this, and using the same principle you can obtain a digital form. It will be slightly different, or something like this, and so on and so forth. So using the simple rule from the digital control system theory, and having common knowledge of the school mathematics, you can receive digital form of the transfer function, and you can evaluate the output of your dynamic block, in our case the correctional link, and you can code it. There are no problem, just 3 strings of code. Of course, you have to bear in mind that this is dynamic processes, and you have to call it at a specific time interval, because this is discrete form. So my sampling time is 100 milliseconds. It can be 10 milliseconds, so it will be 0.01 seconds the sampling time. But the important thing is that it has to be constant, and this sampling time should correspond in every place of the program which you use the dynamic links, because in fact you can add some additional, let's say, correctional link too, but the important thing that you must put the sampling time the same as before, otherwise it will not work correctly. So I hope this information has been useful for you, and you can use these correctional links for the additional accuracy increase in your automatic control systems, which is the accuracy is the problem in many modern systems, and you have to increase it. So by using correctional links you can do it. I would like to see some comments on the topic in the comment section below. If you want me to cover some additional aspects of this digital control system theory and the correctional links, I would be glad to. But that's it for today, and I'll see you soon. Bye.